All right, so last time we left off in the middle of 6.2. We had talked about what the goal is for unit circle trig. And remember, the idea is that when you draw an angle inside the circle, the terminal side is going to hit the edge of the circle somewhere. And the goal is to figure out what the coordinate is for that spot right there. That's the whole goal. We talked about 4 angles yesterday: 0, 90, 180, and 270. And we wrote down the coordinates for those. All those coordinates had what numbers in them? Yep.
Ones and zeros.
Yeah, they all had 1s and 0s or -1, but they all had 1s, 0s, and -1s. So we're going to build off those coordinates today to do some other coordinates, but we'll practice with those first. So we learned about 3 trig functions. The 3 that we did were sine, cosine, and tangent. And a trig function is basically, it's like the square root function. You take a number, you plug it into this function, and it does something to it. Right? Or like the log function. Right? Take a number, plug it in, and the log function does something to it. It's the same idea with these. We're going to take a number, we're going to plug it into sine, and it's going to do something to it. And the way we're going to figure out what it does when you plug it in is based off a coordinate. So if you want to take the sine of an angle, the first thing we're going to have to figure out is the coordinate for it. And the answer for the sine is the y value. If you want to do the cosine of an angle, you need the coordinate. And then you're going to tell me the x value. That's cosine. Those only use the x or the y. Tangent uses both. Okay, so if you want to find, let's see, the tangent of an angle, step 1 is to find the coordinate, and step 2 is to divide the y by the x value. Okay, now there's 3 other trig functions. We don't use these 3 as much. When you write them down, it's a good idea to write them across the way I did. Put sine across from cosecant, you'll see why. So the other 3 are cosecant, secant, and cotangent. All trig functions have a 3-letter abbreviation. Generally, it's the first 3 letters of the word. But with cosecant, we can't do that because we've already used COS. So for cosecant, what they do is they use the syllables. Co-secant, C-S. And the way I wrote these trig functions across from each other, these are what we call reciprocal identities. It means you flip one and it gives you the other. So you might think, well, wait, how would you flip y? Well, think of y as y over 1. What do you get if you flip y over 1? Yeah?
1 over y.
1 over y. And that is the cosecant. It's 1 divided by the y. Same idea for secant. To get the secant, you flip the cosine. So what do you think the secant is? 1 over x. And to get the cotangent, you flip the tangent. So what do you think cotangent is? X over y. So these are the 6 trig functions defined using a coordinate on a circle. So you can see it's very important you know how to get the coordinate, because if you can't get the coordinate, you have nothing to plug into any of these 6 formulas. Now on the test, what I'd probably do is give you a single problem, and it would say, like, find the cosine of 90 degrees. It's not going to ask you to do all 6 of them. It's just going to ask for 1 out of 6. But we'll practice all 6, so that way you know how to do them all. So the 4 angles that we dealt with yesterday, these are the only 4 that you know how to find the coordinate for. or at least that I've taught you how to do right now. 0, 90, 180, and 270. Since all of those angles land exactly on an axis, and the axes divide the coordinate plane into quadrants, we call these angles quadrantal angles because they're in between all the quadrants. Being on an axis is not in a quadrant. All right. So the next thing we're going to do is we're going to do an example. So what are the 2 steps to doing unit circle trig? Step 1, keep saying, find coordinate. Now, sometimes they'll give it to you. That makes it a little easier. If they give you the coordinate, then you're already done step 1. But if they don't, you have to figure out the coordinate. How do you do it for 0, 90, 180, and 270? Well, you memorize it. Pretty much how you do it. There's nothing calculated. You just have to remember, like 90 is 1 to the right, so that's 1, 0. Oh, no, sorry, 90 is 1 up. That's 0, 1. 180 is to the left, so that's negative 1, 0. So even if I don't have these all memorized, sometimes what I do is I just picture it like in my head where the coordinate would be. All right, step 1, find the coordinate. Step 2, plug in the x and the y value into the formula from the other page. Now there were 6 of them. Which formula do you use? Well, whichever one I asked you to use. Okay, we're going to do all 6. Let's try a question. So it says the point that represents an angle is given below. Use this to find the 6 trig functions. So the most important thing that they can give you in the problem is coordinate. If there's a problem where they give you an angle, that's not what you need. You need the coordinate first. Maybe you can get the coordinate from that, but that's what you need. Okay, so we have the coordinate, so step 1 is already done. That's x, that's y. So we're going to fill them into the 6 trig functions and find all 6. So let's start with sine. What's our definition of sine? Yep.
Theta equals y, or equals y.
Sine theta equals y. Yep. And what's the y value in this case?
1.
1. So what we just figured out is this coordinate represents an angle. Hopefully you know which angle it is. Do you have to know which angle it is for this problem? No. You don't have to know that this is a 90-degree angle, but it is. What we just found is the sine of this angle represented by this coordinate. It's 1. Now we're going to find the cosine of the angle, which we know is 90, but you don't have to know that. We're going to find the cosine of the angle represented by this location on the circle. So Caleb, what's our formula for cosine?
Well, for cosine was theta equals x.
Cosine theta.
Oh,
Yep. These all have the trig function in front of them. So sine, cosine. So cosine theta equals x. So what is our cosine in this case?
That'd be 0.
0. Yep. And tangent. Brighton, what's our formula for tangent? tangent equals y over x. So what would I write down in this case?
Over 0.
Over 0. Okay. And what is 1 divided by 0? Yeah.
Not a number infinity. It's undefined.
It's undefined, right? You can't do that. You can't divide by 0. So this one, we would just write undefined. And on the test, you could just write out the word undefined. Or you could write UNDEF. You could abbreviate. Okay. Now let's do the next 3. What's the name of the trig function that we get when we flip the sign? Tell me the name, and then I'll write. I want to know the abbreviation. Yep. Cosecant. And what's the abbreviation? CSC. So to find the cosecant, take the value that you got for sine and flip it. So Eli, what would my cosecant be?
Would that be negative 1?
If we take that and flip it, you don't get negative 1.
Is it 1 over 3? Is it 1 over 0 or 0 over 1?
Neither.
So
What is this number as a fraction right now? Like, how could I make 1 into a fraction? Yep.
1 over 1.
I could just make it 1 over 1. So if we take that and flip it, what do we get? Yeah. 1 over 1. 1 over 1. So the cosecant stays the same. What's the name of the trig function that you get when you flip the cosine? Yeah. Secant. SEC. And let's start with 0. How could we make this a fraction, just so we can think about what we're going to be flipping? Yeah?
0 over 0. Or 0 over 1.
0 over 1. So we can put it over 1. So what am I going to get when I flip the cosine to get the secant? Yeah? Undefined. Because I have 0 in the bottom. All right. So when you flip 0, you get undefined. When you flip undefined, what are you going to get? Yeah? 0. So the cotangent is 0. And that's it. That's the 6 trig functions for the coordinate 0, 1. And what angle did we say that that was again? If you just don't go left and right, but you go straight up. Yeah. That's the coordinate for a 90-degree angle. Let's try another one. Let's look at this one. 1/2, comma, root 3 over 2. Does that look like the coordinate for 0, 90, 180, or 270? Does it look like any of them? No, it's not. What is it the coordinate for? You don't need to know. You will by the end of today. But the most important thing here is you have the coordinate. If you really want to know what it's the coordinate for, it's the coordinate for 60 degrees. But you don't need to know that. All right, so let's start by finding the sine of the angle, which we're going to pretend we don't know, represented by this location. What is my sine? Yes?
Square root of 3 over 2.
Square root of 3 over 2. Good. Okay. How about my cosine? Caleb? 1/2. And Maddie, how do I get my tangent? We're going to do y over x. Well, we already have y over x written right here. So what I do visually is just imagine doing this. if you divide those two, that's the tangent. This is the y, this is the x, and we're going to divide them. Now, when you divide a fraction by a fraction, you're supposed to take the second one, flip it, and multiply. If I take the first one and leave it, and take the one that I'm dividing it by and flip and multiply, what ends up happening?
The 2's cancel out.
The 2's cancel out. So whenever you divide two fractions with the same denominator, you can just cross the denominators right out. Okay, don't cross them out though, because you need to see your answers. So what you're left with if you cross the 2's out is square root of 3 divided by, the 2's are gone. The only thing you have in the bottom is a 1. So it's really just square root of 3. And you could see the same thing here. If you flip and multiply, the 2's cancel out, and you're left with the square root of 3. Okay, so that's my tangent. Okay, and Alva, what am I going to do with the 3 that I have here to get the next 3?
You're gonna divide it by the something to the square root of 3. But
So what did we do like to get the secant, or the cosecant, or the cotangent in the last one? We took each one of these and we...
I wasn't paying attention.
Right. Even help them, what did we do? Yeah? We didn't do any addition to change this answer into this answer. Yeah?
You would divide 1 by 3, or square root of 3, wait, square root? Yeah, of 3 divided by 2.
Okay. So what does that really mean we're doing? Yeah?
Find the reciprocal.
Finding the reciprocal. Yep, we're flipping it. So all we have to do is flip those to get the other 3. That's what 1 divided by means. Flip. All right, so my cosecant. When I flip that, Eileen, what's my cosecant going to be?
2/1.
That's going to be my secant. So we'll do that one next. But let's do this one first.
2 over the square root of 3.
Okay, so we get 2 over the square root of 3. And then what's wrong with that? I mean, it's okay so far, but we got to fix it. Yep.
The square root in the denominator.
Right, we have a square root in the denominator, so we need to fix it by multiplying top and bottom by square root 3. And that's going to give me 2 root 3 over 3. So that's the only thing that gets a little annoying. When you get a square root in the bottom, you do need to fix it. Okay, Eileen already gave us the secant. That's 2 over 1, or just 2. And lastly, my cotangent. You don't have to fix it right away. I just want to know what the first step would be to get the cotangent. Yeah?
1 over the square root of 3.
Yep, it'd be 1 over the square root of 3. And can anybody tell me what that would be once you fix it? Yep.
1 times the square root of 3 over 3.
Yep, so 1 times the square root of 3 over 3, so I'm just going to say square root of 3 over 3. Because 1 times the square root of 3 is just square root of 3. There you go. There's all 6 trig functions. Any questions on that? Yeah.
Kind of confused with what you just did on the last one when you said to fix it.
So we multiplied the top and the bottom by the square root of 3.
Okay.
So anytime you want to get rid of a square root in the bottom, you multiply the top and the bottom by that square root. And we're gonna do more of those. Definitely, we'll have more. All right, let's look at this one. Find the 6 trig functions of 90 degrees. What's different about this one? Yeah.
We have the degree and not the coordinate.
Right, you're being given the angle. That's not helpful. We can't do unit circle trig until we figure out the coordinate. So what I do is just think of 90. 90 means you go straight up And what's the coordinate when you go straight up?
0,
0, 1. Now from here, you'd fill in all 6 trig functions, but we already did that. We just did the problem with 0, 1. So now, example 1a is all the answers to this one. Doing the same problem again. The only additional step was to find the coordinate first. Is there any question on how you get that coordinate? Yeah.
So when you find that coordinate, it's just a matter of like forming a circle around it. How do you come to the determination of that graph using only the one?
Because when you draw a set of axes, I know 0 is right, 90 is up, 180 is left, and 270 is down.
Sure.
So I know 90 is straight up, and I know that this circle has a radius of 1.
But that coordinate is always going to be on an axis, or is it?
For 0, 90, 180, and 270, yes. For anything else, no. But we haven't talked about when it's not on an axis yet. When it's not on an axis, you're going to start to get coordinates that look more like this. But we haven't really gotten there yet. Yep.
So, in the test, if you say like find the sine of 90 degrees, we just put all of those 6.
No, if I said find the sine of 90 degrees, then you would only pull that one answer.
Okay.
So the way it's going to be set up on the test is I might say like find the sine of 90 degrees. So I'd be looking for 2 things. Tell me the coordinate for 90 degrees, and then tell me the answer that would go in that box. And that's all I would be looking for if I said find the sine of 90 degrees. Yep.
If the radius were to be like 2, would it then be would 0 to be 90 degrees?
Yes, you could. So that's non-unit circle trig. These formulas that I gave you at the beginning change slightly if the radius isn't 1.
Right.
All these 1s turn into what the radius is. So like 2 over y in your case and 2 over x. But we're not really going to do that. But yeah, all these formulas change a little bit. Basically, everywhere that you have a 1, it would change to a 2, or a 3, or a 4, whatever your radius is. But 1 is easy to work with, so that's why we do it. All right, let's do this one. 270. Okay, what's the first thing I need here? Yep,
To find the coordinates.
I need the coordinate. So I imagine my unit circle diagram, and I try to think where 270 is. 270 is, yep,
0 and -1.
right. It's when you go down 1. So there's our coordinate. And now we fill in everything. All right, so let's do, so the sine would be your y. The cosine is your x. And the tangent is when you divide the sine by the cosine. What do I get in this case when I divide the y by the x, which is sine over cosine? Yeah.
-1 over 0.
Yep, which is,
You can't do that.
we can't do that. So we're going to write undefined. You can either write out the whole word or just write an abbreviation. Okay. What's my cosecant?
When we flip the first one.
Yep, when we flip the sign. So when I flip that, what's that going to give me? Yep,
It's going to give you 1 over -1, which is -1.
-1. When you flip -1 or +1, it stays the same. Those are the only 2 that don't change. How about when we flip 0? Yep,
Is it undefined?
that's undefined because 0 ends up in the bottom. And what about if we flip undefined? Yep,
You're going to find 0.
we're going to get 0 because now it's in the top. So when you're dealing with 0, 90, 180, or 270, all the answers are one of 3 things. 4 things. 1, -1, 0, and undefined. there was no positive 1 in this problem. But those are the 4 answers you can always get for a quadrantal angle. Okay, pi. What might we want to do with pi first to make this easier? Because eventually we want to get the coordinate, but we could probably make pi easier to think about. Yep.
Converted degrees.
I would convert it to degrees. What is pi the same as in degrees? Yep.
180.
That's 180. Okay, so now we've got something a little easier to think about. Imagine where 180 is. It's halfway around. And what's the coordinate if you go halfway around for 180? Yep.
-1, 0.
-1, 0. And now you would take the -1 and the 0, and you would fill them into all your formulas. Is there any questions on how to fill those in? Yep.
Are the secants and the tangents always going to be like equal to the same unit? Because like I know it's kind of a pattern in like the wrong derivative where like the tangent and the secant always equal the same thing.
No, they won't always equal the same thing.
Okay.
Yeah. And you'll see more of that later today. All right, let's try this one. Find the 6 trig functions of 7 pi over 2. Well, what I do with a problem like this is I look at the pi over 2. We just did pi. Forget about the 7 for a second. This is half of pi. So what's pi over 2 in degrees? Yeah? 90 times 7. So what's 90 times 7? Yep.
630 degrees.
That's 630 degrees. Now, even changing it to degrees, that angle's too big for me to really think about on the circle. So we talked about something you can do to that angle to make it smaller. Max?
You're gonna subtract 360.
Yep. We're going to take 630. We're going to subtract 360. And we get 270. So 270 degrees. We just did that. It's example 3. So this problem is exactly the same as example 3. It was written a little different, but every answer is the same. Question on it? All right. And how about this one? It's kind of like the problem we just had, but it's like we have the opposite issue this time. We have a negative 90 degree angle. It's in degrees, but I'd rather not have to think about an angle that's like that. So what could I do to make that angle easier? Yep.
You just subtract 90 from 360.
Yeah, we can add or subtract 360. That's the key. So let's add 360 to that. And what does that give me?
270 degrees.
It gives me 270 degrees, which is exactly the problem we just talked about, which is exactly the problem we talked about before that. So it's the same question again. So you might see different numbers here, but it really might mean the same thing as something else. All right, good question on that. Okay, so let me pause that for a second. All right, so the last part of section 6.2 first is going to focus on angles besides the quadrantal ones. So we've already found the 6 trig functions for 0s, 90s, 180s, and 270s. What we're going to look at now is finding the 6 trig functions of 30s, 60s, and 45s. These are all angles that are in the middle of a quadrant. And once we know how to work with 30s, 60s, and 45s, we can work with any multiple of 30, 60, and 45. like 120 or 150. Those are multiples of 30. So the whole focus again is on figuring out coordinates. So we need to first talk about a 30, 60, 90 right triangle and a 45, 45, 90 right triangle. Because a triangle is how you figure out the coordinate when it's not on an axis. Let me show you. Here's your circle. Here's a point. And let's say you want to figure out the coordinates of that point. The coordinate is from the origin, how far to the right do you go? That's the x value. And then how far up do you go? That's the y value. And if you draw in the radius, you just made a triangle. So the whole goal of this part is to make a triangle and figure out the base of the triangle. That's going to be what we call the x coordinate. And the height of the triangle. That's going to be the y coordinate. But there are only two triangles we need to focus on. The 45, 45, 90, and the 30, 60, 90. We're not going to be focusing on any other angles besides those. So there's a 45 degree angle. If this is 0, and this is 90, 45 degrees would be exactly halfway between the two. We want to figure out how far over and how far up. Now, we don't know at this point, or at least I haven't taught you yet, how far over and how far up. But look at this triangle. If you compare how far over you're going to go to how far up you're going to go, how do you think the lengths of these two red sides compare? Yeah?
They're the same.
They're the same. If this is a 45 degree angle, bless you, we know that all the angles have to add up to 180. Well, if this is 45, and this is 45, and the bottom is 90, then they would all add up to 180. So that's an isosceles triangle. So I have the same triangle, just a little bit bigger down here. Now remember, this side in red, that's the radius of the circle. That's this side right here. Well, we're working with a unit circle, so we already know the radius from the center to the edge. What's the radius of my circle? Yeah?
The radius is 1, right?
The radius is 1. And we don't know the base, and we don't know the height, but we know they're the same. So what we want to do is pick a letter to represent them, but use the same letter. If you use a different letter for the base and the height, then you're assuming the base and the height are different, and they're not. So let's just call this x, and we can call that x. It doesn't matter what letter you use. You could use A, B, whatever letter you want. But when we have a right triangle, and we know one of the sides, and you want to find the other one, what theorem can you use to do that?
Pythagorean.
Yep, we can do the Pythagorean theorem. So can you set up the Pythagorean theorem for me, filling in the x, and the 1?
Yeah. It'd be x squared plus b squared.
Plus what?
Oh, plus x squared equals 1.
1
Squared.
squared. There we go. So there's our Pythagorean theorem. So that's going to give me 2x squareds. And 1 squared, that's just 1. What would be my next step to get the x squared by itself? Yeah?
Divide 2.
So divide by 2. So we get x squared equals a half. But I don't want to know x squared. I want to know what x is. How far over and how far up. So what do I have to do to get rid of that exponent of 2?
Find the square root of both sides.
Yep, take the square root of both sides. And to square root a fraction, you just square root the top and the bottom. That's how you do it. Well, the top is fine. What's the square root of 1? 1. Unfortunately, the bottom is not fine because I can't simplify the square root of 2. But can anybody tell me what I get when I fix that, just like we did on the last section? Max?
The square root of 2 over 2.
Yep, it's the square root of 2 over 2. So x, which is this bottom side, it's the square root of 2 over 2 on the bottom, and it's the square root of 2 over 2 for the height. So now, this is my origin. I know how far over and how far up I go to get to this point right here. Let's fill it in. How far over do I go to get from here to there? Yeah?
Square root of 2 over 2.
Square root of 2 over 2. And then how far up do I go to get from here up to there? Square root of 2 over 2. So that is always my coordinate for 45 degrees. We don't want to have to go through and figure that all out again. So now we just want to memorize or put it on your reference sheet that the coordinate for 45 degrees is always root 2 over 2, comma, root 2 over 2. Now I said once you know what the coordinate is for 45, you should be able to find the coordinate for any multiple. Here's 135 right here. It's a mirror image of the triangle in quadrant 1. So what do you think the coordinate would be for 135? Just be careful because it's in quadrant 2, but it is a mirror image of the triangle in quadrant 1. Yep.
Negative root 2 over 2.
Yep. 2 over 2. Every 45 degree angle and multiple is always a root 2 over 2 with a root 2 over 2. Sometimes they're positive, negative, or one of each. So you should also be able to do 225. That's 45 times 5. And does anybody know what the 45 is over in that quadrant? Yeah?
Your third quadrant? Is that what you're saying?
This one. 45.
Okay, it would be negative root 2 over 2 and negative.
Just the angle.
Oh, the angle?
Yeah.
No.
Do we know that? Yeah?
315.
315. The number is always halfway between the two numbers on the axis. So like halfway between 180 and 270 is 225. This is 270, and this is really like 360. So all your 45 degree angle coordinates are all root 2 over 2s, just some positive, some negative, and then sometimes one of each. Yeah, I'm not going to write every single one of them out. It starts to get a little messy. But that's the idea. Yeah.
Did you go from like a root 2 over 2 to 90 degrees? And how would you get root 2 over 2 to 0? You know what I'm saying? Like 90 degrees is also 45, right?
Yeah, it's a special case because it's right on an axis. But yeah, because it's on an axis, the coordinate is a 0 and a 1. If it's on an axis, it's always a 0, a 1, and a negative 1. Axes are the easiest coordinates. This one's a little harder because it's in the middle. But there's the diagram for your 45 degree angles. You only really need to remember this first one. That's all you need to remember. All right, now, the 30, 60, 90. Well, first thing you'll notice about 30 and 60, they're the same triangle. The 30 triangle and the 60 triangle is the same triangle, just kind of like stood up and then flipped around. But they're exactly the same thing. So once you figure out the long side and the short side for one of them, then you have both of them automatic. Let's focus on this one first. So this angle at the bottom is my 30. And this angle at the top is my 60. It's 30 degrees by the origin, because that's what you'd have to tilt the hypotenuse at, so it points at 30 degrees on the circle. Now, how long is this side? Yeah?
It's 1.
It's still 1. Now, can I do the same trick as last time and label this X and this X? What do you think? Yeah?
They have to be two different things.
They would have to be two different letters. And the problem with putting an X here and a Y here, which will not work, is that you're going to have two different variables. So now you'd have X squared plus Y squared equals 1 squared. So we can still use Pythagorean theorem, but we have to figure out one of the other sides first, a different way somehow. And my hint at how you can figure out one of the other sides, just being a little clever, without really having to do any difficult math, is to go like that, and then go like that. So anyone have a thought what I could do now? Mm-hmm.
Is the bottom line the same as the slanted line?
The bottom line, is this the same as the slanted one? Length? No, the slanted one is longer because it's a hypotenuse. So the red line is longer. Anyone else have a thought what I could do with these two pictures now? Yeah?
They combine them together.
Mm-hmm. Let's combine them together.
So it's like 66.
So what did I just create there? Yeah. That's an equilateral triangle. 60, 30 and 30. 60 and 60. And what do we know about an equilateral triangle? Yeah?
All the sides are the same length.
All the sides are the same length. So this red side is 1. This red side is 1. But the most important thing is this side is 1. And what do we know about the segment in green compared to the segment in blue? Yeah?
They're the exact same.
We know that they're the exact same because they're a mirror image of each other. So the green one and the blue one are exactly the same. And what do they add up to? Yeah?
They add up to 1.
They're exactly the same and they add up to 1. So that tells you what they are. How long are they? A half. So now we know this side is a half. Pythagorean theorem will work now because we only have one side we don't know. Just a little clever way to figure out the side if you don't know it. Now, we don't need the bottom one anymore, so I can just move it out of the way and just focus on the top one. Okay, so let's call the bottom side x. And now let's do our Pythagorean theorem. So x squared plus a half squared equals 1 squared. Okay, what's 1/2 squared? 1/2 times 1/2. Yeah. 1/4. So x squared plus a quarter equals 1. If I move the quarter to the other side, what's 1 minus a quarter? Yep. 3/4. And I have to get rid of this exponent of 2 by square root. And this time the square root is good because I'm going to take the square root of the top and bottom. Square root of the top doesn't come out nice, but I don't really care about that. What's the square root of the bottom? Yep, 2. So now I know the length of this bottom side is square root 3 over 2. So looking back at our circle, this side is root 3 over 2. This side is 1/2, and that gives us our coordinate. The bottom is the x, and the height is the y. So root 3 over 2, comma, 1/2. Now, look at the 60-degree triangle. It's the same triangle as the red one. But what's going to happen in the coordinate for the 60 compared to the 30? Remember, the red and the green are the same triangle. Yep.
The X and Y are going to swap.
Right. The x and the y are going to swap. This is going to be your 1/2. That's going to be your root 3 over 2. So how do you remember which side is which? In the 30, 60, 90, there's always a short side and there's always a long side. Out of the two numbers, 1/2 and root 3 over 2, 1/2 is 0.5. Root 3 over 2 is 0.87, roughly. Root 3 over 2 is a bigger number than 1/2, a little bit bigger. So when you look at the 30, 60, 90 triangle, the bigger side is always the root 3 over 2, and the short side is always the 1/2. Short side, smaller number, that's the 1/2. Long side, bigger number, that's the root 3 over 2. So now, if you look at that coordinate, and we go back to one of the questions that we just did, where I gave you a coordinate. I gave you this one, and I said, does that look like anything that we've done before? And you said no. And I said, well, it is the coordinate for 60 degrees. And we already practiced doing all the arithmetic using these kind of numbers. The only thing is, you just didn't know how to get these numbers. Well, now you do. That's the coordinate for 60 degrees. 1/2 root 3 over 2. All right, so let's try a couple examples with 30s and 60s. Find the 6 trig functions of 45 degrees. What do you think the first thing you need if you want to do unit circle trig is? Yep. You have to get the coordinate. Now, we do not want to have to go back through and figure the whole coordinate out from scratch again. You just want to put that on your reference sheet so you have it. So think of a 45. And think of the numbers. The 45 is the two numbers that are the same. And we're in quadrant 1. Manny?
Root 2 over 2.
Yep. Root 2 over 2. Root 2 over 2. And now from here, go through all your trig functions. What's my sign going to be? Yep.
Root 2 over 2.
And which one? Just so I know which one you picked.
Oh, because it's y.
The y. Yep. 2 over 2. How about the cosine of 45? Yeah.
Root 2 over 2.
In this case, it's the x, so root 2 over 2. And now the tangent is when you divide the y by the x. But the y and the x are the same. So what are we going to get when you do the tangent? Anthony? 1. Since we're right here, let's do the cotangent. What do you get when you flip 1? 1. That is the easy one. That's why I did it first. And now the cosecant. So we have to flip root 2 over 2. And we get that. And what would that clean up as? Yep.
2 times the square root of 2 over 2.
Yep, it would be 2 times the square root of 2 over 2. But then those 2's would cancel. So all you're left with there is the square root of 2. And how about the secant? Yeah?
Same thing.
Same thing, because the sine and the cosine were the same. So they are the 6 trig functions of 45 degrees. Let's try 30. So 30 and 60s are a little trickier because you have to get the 1/2 and the root 3 over 2 in the right order. So think of 30 degrees. I know it's these two numbers. I have to figure out which one goes where. In your head, or on paper, draw your circle, and put 30 degrees roughly where it should be. It should be lower on the circle. 60 would be higher. Okay, so put your 30. Make your triangle. And if you draw it reasonable, there should look like there's a short side and a long side. That's the long side. That's the short side. Which number is always the long side in this triangle? Yep.
Square root of 3 over 2.
Yep, that's the long side because that's the big number. And what number is always the short side? Yep, 1/2. And that's how I think through the coordinate. I visualize the short and the long side. So the coordinate is root 3 over 2 for the x, 1/2 for the y. Or you can just memorize it. But I think it through like that every time. And now the 6 trig functions, we really just practice that in a problem like this. This time it's root 3 over 2, 1/2. This one was 1/2 root 3 over 2. But the arithmetic is pretty much the same. All the answers, you're just going to switch places. That's all that's going to happen. So any questions on how you would plug that point in? It's just like the second one in the video from today. This is the second one in the video because this is pi over 3. What's pi over 3? If you write that in degrees.
60 degrees.
60 degrees. And we just learned the coordinate for 60 degrees is 1/2, comma, root 3 over 2. That is the exact problem we did earlier in the video. 1/2 root 3 over 2. The only difference is now you have to be able to get that coordinate without me giving it to you. So that's a 60. Yeah.
So, how did you get pi over 3 to like 60 degrees?
So to convert between radians and degrees, multiply by pi, divide by 180. Multiply by 180, divide by pi.
Okay.
So it becomes 180 divided by 3, which is 60. Changing to degrees isn't necessary here. I change to degrees because I can visualize the circle better in degrees than I can radians. But some people that can do everything in radians might not have to do that. All right, let's try this one. We already talked a little about it, but 135. First, I want to figure out, is this the 45-45-90 problem, or is this a 30-60-90 problem? Here's 180. Here's 90. Where's 135? Is it right in the middle? Is it higher up in the circle? Or is it lower in the circle? If it's higher or lower, then we're going to have a short and a long side. If it's right in the middle, we're going to have the problem where the two numbers are the same. Yep. It's right in the middle. 135. Draw your triangle. And what is the length of each side of the triangle when it's right in the middle? Both sides are going to be, yeah,
The same.
both sides are going to be the same. And what's the number? Number.
Oh, the number? Is it square root of 2 over 2?
Yep, both of them are root 2 over 2. Now we just have to be careful when we write the coordinate because we went left and up. Left, up. So what's going to be the coordinate for 135? How far left and how far up? Yeah.
Negative square root of 2, 2, and then square root of 2.
Square root of 2 over 2. Okay. So now let's write down the sign. Chris, what's my sign here?
Wouldn't that be?
Not negative, square root of 2 over 2.
Square root of 2 over 2. What's the cosine of 135 degrees?
Negative 2.
Negative what?
2 over 2. Oh, square root of 2 over 2.
Square root of 2 over 2. Okay, so negative square root of 2 over 2. And the tangent is when you divide the y by the x. But the y and the x are opposites. So what do you get when you divide opposites?
-1.
Negative 1. In this problem, they didn't ask for the other 3. You would flip them, but they just asked for the first 3. Any questions on that? All right. So at this point, I think you would be able to do every question on the test. Actually, I think you'd be able to do every question. But we'll practice a few more of these tomorrow. Probably in the first 40 minutes. And then the last 40 minutes, we'll start the test. And then you'll have another 40 minutes on Friday to finish the test. So you can ask me any questions Friday before you finish the test. You might be able to finish the test tomorrow.
If we don't finish the test tomorrow and school gets canceled on Friday, yeah, will we just take it at home?
No, I'll have to think about it. I might just, I don't know. Yeah.
So, on Friday, did you say we go to homeroom first and then come here, or?
Yes. Okay, so for homework, I just need to adjust that a little bit. 13 through 16, that should be okay. Okay, so tomorrow, what I'm going to check is what's in that red box. 13 to 16 and 21 to 24. 29 to 32 is using a calculator, because if we have an angle that's not a multiple of 30, we're not going to be able to find a coordinate. So I'm going to show you how to type it in on a calculator. It's very easy, but I just haven't shown you yet. Same with 37 and 39. This is all calculator. So what's not in the red box will be homework tomorrow night. What's in the red box is the homework for tonight.